Hello everyone, my name is Craig Otto. I'm a Lean Six Sigma Master Black Belt. Welcome, this is a Yellow Belt training. If you'd like more information, you can go to www.autoopx.com. And today we're going to do the second video of the Yellow Belt series. Video 1 kind of set the table of what we're looking at with current state. And now we're going to demonstrate that through the Lego simulation process. And so we'll go ahead and show you a little bit about the Lego truck factory. This is the Lego truck that we're going to use on the left, and then there's certain stations that we use to build it up, actually 4 different stations. And we also are going to do this just like a real Lean Six Sigma process where we do a value stream analysis. We kind of talked about that in video 1, where we capture all of the current state data that you can see here, everything from the number of steps, whether they're value added or non-value added, the amount of inventory, the batch size, the cycle time, the distance that we travel, the lead time, space, quality, and efficiency, all that good stuff. And then, of course, profit and loss for the business. And then we have, through the value stream analysis, we have a current state that we develop through the VSA event, and that is used for the remaining sub-events, which are known as rapid improvement events, and sometimes problem-solving corrective action. In this particular example, we're going to use a value stream analysis from what we did on the Lego truck simulation, and here is our project charter. Our mission is to reduce waste and variation within our little factory here, and the scope will be everything performed in the current state, and then we're going to do 5 different iterations here where you can see the power of each of the individual tools as we implement them, whether it's one-piece flow, 6S, standard work, or pull systems. And our goal is obviously to reduce lead time and inventory at least by 75%. We want 0 defects from a quality perspective, and we want to improve our efficiency by 50%. This should help us achieve the profit greater than 50 units. And then our team roles, there's going to be 4 operators, and we'll have a little plant director, material handler, and maybe an OpEx practitioner. This is a simulation that I typically do in person, but I wanted to get it on video just so you can kind of see what we do for in-person training. And of course, as we do this, we treat it just like an event. So we want to use the A3 method. You see my 9 boxes for the A3 here. The first box is the top left, the issues to be addressed. If you're not familiar with this process, you can find some of my other videos where I kind of demonstrate how this works. But we start from the top, work our way down. So issues to be addressed, current state, future. And then we go to the middle with the gap analysis, improvement approach, and rapid experiments. And then all the way to the right with the action items and confirmed improvements and lessons learned. And so to start off, typically what we do is put the charter goals in there, or deliverables. So you can see I put in there, there's no 6S in our current state. We don't have standard work on the Lego simulation. We don't have a pull system. Everything's in batches. And then our metrics, I also shared those with the goals. And that's typically what you want to put in this issues to be addressed phase. And then the next thing that we do is we observe. And so here we step into the Gemba. This is where we see the work being done. Again, I mentioned earlier we have 4 operators. The top left is operator 1. The top right is the operator 2. Top or bottom left is your operator 3. And bottom right is operator 4. And so you can see I've sped up the build process. But the way this works is each of the different stations builds up 5 for our WIP. This is similar to what you do in departments. You'd build up a batch, and then you'd ship that batch on to the next department. So that's kind of what each of the different operators represent. Let's make some other observations. The parts obviously aren't organized. They're just dumped in a bag. There's lots of little parts, especially in Station 2. You can see several different pieces. And the build sequence, if you look carefully, the parts are not always assembled in the same way, even though it ends up getting done. Well, and sometimes you could have quality issues because things aren't getting done the same way every time. Now, if you take a look as well and watch closely, Station 1 does take a lot less time. It's very quick. And compare that to Station 2, you can see it takes a lot more time. It's much more difficult. And so that's also relevant as the factory itself tries to output as much as it possibly can to make as much profit as it can. And the other thing is you can see that the parts don't leave the area until we have those 5 WIP completed. And then just in general, you can see a lot of different motion as well as the operators reach and dig and try to find all the parts. Now, what I've done to save us some time, I've taken our 5 different iterations within our factory and broke them down into the current state, which is what we just observed. So you can see all of our metrics, the 4 across the top, 4 across the bottom, everything from quality to the amount of inventory we had to the amount of space and how many vehicles we shipped. You see we have a major quality problem. We have 15 units built and 10 of them had quality issues and 5 were only shipped without any issues. And efficiency, very low. Lead time, very long. Our batch size is huge. And our profit is, you can see, negative as it went below the break-even line. So this is a major concern. And so what I'm going to do is, as we train each of the different lean tools, we're going to go ahead and do a round of simulations so that you can learn and see what does that particular tool do for the performance of the factory. And you'll find that all 4 core tools are very powerful when it comes to these types of metrics here, which is typical of what most businesses have with their performance. And then, of course, we don't ever want to forget the A3. The A3 is a living document, and so after you make those changes, you'll want to capture the current state. In other words, you observe all of that happening, and we did as we watched the videos. I made a couple of little notes off to the left there. You'll make those types of notes to document the waste. You'll also take time observations to see how long each of the different stations are taking. And so when you do that, you're able to put in your data, like I just showed with our performance. You're able to put in something we call standard work and bar graphs, and you can see the balance of the work and who has more work, who has less, and so forth. And all that can be documented in your A3 under your current state. And then as we go forward into the next session, we'll learn about that future state of what we're going to do, the power of the tools, how we're going to implement those, and we'll do experiments as we go through. And so just to kind of close up the follow-up session here from video 1. Again, video 1, we kind of set the table that we're going to work on our little Lego factory and do a value stream analysis, kind of get things ready for rapid improvement events. That's kind of what we've done today with data and observation. And so the first thing I want to note for everyone to remember is to make sure you let the charter guide the improvement efforts. That makes sure you're within scope and including collecting all of that current state data that your charter calls out. Super important. The next thing is always look through a lens of flow. Make sure that your factory is flowing. How well does the product move through the plant? If there's bottlenecks, if there's stoppages, those are key points, and that's important to document what those things are so that you can address those in the rapid improvement events to come. So when you're observing current state, it's also important to make sure you do capture those relative business metrics and then also quantify that waste. Just as I was mentioning, if you can capture and quantify it, that way when you go in and make changes, you're able to compare before and after to see what differences you've been able to make. And then, of course, use the A3 method to document the improvement process. That is a living document, so keep it updated as you go through and execute the events. Okay, so that'll wrap up video 1 follow-up of Yellow Belt training. Thank you for joining me. Don't forget to like and subscribe, and make sure you check out ottoopex.com for more information. Thanks, and we'll see you next time.